Okay, so you try the other three and see if you can figure them out. The next series, you've got four quadratics. I'm gonna look at number 20. So I'm gonna get everything on the same side. I'm moving these over. So I got x squared. It's gonna be minus 10x minus 96 equals 0. Okay, I'm gonna still in love a little bit because the a is 1. And I'm gonna always try and factor it if a is 1. So it's got a times give me 96, negatives, add and give me negative 10. Okay, 96, I don't really know much about 96. 1 and 96. 96 divided by 2. 2 and 48. 3 will work. 96 is that 32. 4 will work because it's 4 less than 100. 4 and 24. 5, no, 96 divided by 6. 6 and 16 works. Let's try 8. 96 divided by 8. Holy cow, this has a lot. 8 and 12 works. 9's not. 10's not. 11. Okay, we're done. Now, I've got to get a negative 10. That's a 10. Negative 10. Alright, we can get it. Pretty sure we can get it right here. So it is gonna work. I was hoping it would not work. This one's gonna work. 6 and a 16. But to get a negative 10, I want the 16 to be negative. So I'm in business. Here we go. X minus 16, x plus 6 equals 0. So your answer is going to be 16 or negative 6. Okay, that one worked. I want to find one that does not work. So let's look at 22. 22, is 22 going to work? I don't think it's going to. So I'm going to have x squared minus 6x. If I bring the 3 over, minus 3 minus 3, that's going to be 54. Okay, let's try 54 and a negative 6. So it's got a times give me 54, add and give me negative 6. 54, here we go. 1 and 54. 2 and 27. 3, does 3 work? I think 3 does work. 54 divided by 3. 3 and 18. 4 does not. 5 does not. 6 and 9. I think that's it. Okay. We're in business now. I got 4 options. Any of these options going to add and give me a negative 6? And the answer is no. So I'm in trouble. And I'm in trouble because the 54 is bogus. I don't want a 54. So here's what I'm going to do now. We're going to complete the square again. So I'm going to take this 54 back to the other side. So I'm going to have an x squared minus a 6x equals negative 54. Okay, I'm going to replace it with a number of my choosing. So remember, I want it to be a perfect square. So I want something that adds itself and gives you the middle. So take b, cut it in half. That's going to be negative 3 and negative 3. And if I times those together, that's going to be 9. So I want a 9, not a 54. So I'm going to scoop 54 to the other side. Put 9 there, but I've either got to take it right back away, or if I put 9 on this side, then I can put 9 on this side. And that's the exact same thing as taking it right back away. Okay, now I'm going to change this to x minus 3 times x minus 3, which is a perfect square. Okay, I'm going to come up here, x minus 3 squared. And then a minus 54 and a 9, what is that? Equals a negative 45. Okay, now let's undo the square. So how you undo a square is you do the square root. Square root this side, square root this side, but I got a square root of a negative. So that's going to be, this side undoes itself. So I've just got x minus 3, and because I did the square root, I'm going to go plus or minus. the square root of 45, and I'm going to take the imaginary out. Because the square root of negative 45 is the same thing as the square root of negative 1 times the square root of 45. And square root of a negative 1, that is your imaginary. So just write that as I. Okay. Now undo this minus 3 plus 3 plus 3. So there you go. 3 plus or minus an imaginary times the square root of 45. But square root of 45, you're going to break that up to a 9 and a 5, a 3 and a 3. So if I come over here, I've got 3 plus or minus I times the square root of 3 squared times, oh dear, 3 squared times 5. So it's going to be 3 plus or minus 3i times the square root of 5. Because 3 squared is going to come out. That square root is going to undo the square. So 3 plus or minus 3i times the square root of 5. So if it does not work, they give you a number that's going to make it so it does not work, just kick that number to the other side, replace it with the number of your choice, complete the square, and you should be in business. Okay, this last series, if we look at a problem like 24, okay, I'm going to get everything on the same side. So I'm going to plus 6b squared plus 6b squared. And the 4, I'm going to minus the 4, but it lines up with the 8. So I'm going to minus, there we go. So I'm going to have 11b squared minus 4b plus 4. And on the right hand side, I got 0. Okay, this is an ugly problem because A is 11. And B and C, these three have nothing in common. So because of the ugliness of this problem, I'm just going to go straight to the quadratic formula. Quadratic formula, whenever a problem is too messy, let's just use quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So it's in standard form, so I can find a, b, and c easy. A is how many squares you got, b is how many linear pieces, how many x's you got, and c is how many numbers you got all by themselves. So there we go. X equals a negative b. Our b is already negative, so that's going to turn it to a positive. Plus or minus the square root of b squared. Put that in parentheses or you're going to miss it. Minus 4 times a times c all over 2a. That's 11. Okay. Now, if you just want to copy and let's do this in your calculator. Do parentheses negative 4 squared minus 4 parentheses 11 parentheses parentheses 4 parentheses. If you punch that in first, that is your first move. So it's going to be 16. Alright. We're going to go 4 plus or minus. Should get negative 160. All divided by 22. Okay. Now, it's going to be imaginary, so let's take the imaginary out. So it's going to be 4 plus or minus an imaginary times the square root of 160 all over 22. Okay, 160 is a big number. Let's see what is in 160. How many squares are in 160? 16 and 10. That's 4 and 4. That's 2 and 2 and 2 and 2. And a 2 and a 5. So 160 is 1, 2, 3, 4, 5, 2 to the 5th times 5 to the 1. Okay, there's a few squares I can take out. 2 to the 5th, how many 2's are there in 5? There's going to be 2. So 2 come out. 1 stays in. So on the outside, I'm going to have a 4, and on the inside, I've got 10. So here we go. I'm going to rewrite this as 4 plus or minus 4i times the square root of 10 all over 22. And I know that I can divide both those by 22. 22 and 4, and 22 and 4, I can divide all those by 2. So my final answer is going to be 2 plus or minus 2i times the square root of 10, all divided by 11. Alright, fill in the blanks. This one grows by multiplication. 2 times 2 gave me 4, so that's going to be 8, 16, 32. Times 2 times 2. Let me skip to this next one. This one grows, it's linear, so this one grows by addition. 2 plus 2 plus 2, so it's going to be 6, 8, 10. Okay. Now, if I want to fill in the blanks on this linear one, I need to cut this in half. I need to cut add 2 in half, which is going to be still add 1. Add 1. So if I want to cut addition in half, and I'm adding by 2, I'm just going to add 1. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this is kind of a hard concept to follow. If I want to cut times in half, it's got to be 2 equal parts that times and give you 2, just like this. A plus or a 1 plus a 1 has got to equal the 2 because that's what you're adding by. So something times something has to equal the 2 because that is what I'm timesing by. So this idea of what times what is going to be 2, how do you cut times by 2 in half? How do you cut add 2 in half? That's easy because you're familiar with it. It's just plus 1 and plus 1. What I do is I divide this by 2. But you cannot divide this by 2. 2 divided by 2 is 1, and 1 times 1 is not 2. So what you do is, let's see, you actually take 2, you know this, 2 to the third is repeated multiplication. This is 2 times 2 times 2. So when I have a whole number here, I'm multiplying. What I want there is this. I want to take this base, I'm multiplying by 2, and I want to cut it in half. That's what I'm doing. And that's the same thing as the square root of 2. So right here is going to be square root of 2, and this is going to be square root of 2. Because a square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2, so that works. So if I want to cut times 2 in half, it's actually this right here. This is the idea. So this just introduces exponents that are not whole numbers, they're fractions. And what that 1/2 means is I'm cutting times by 2 in half. So let's look at, here's where you see it, here's how you see it. Look at these guys. Write them as radicals. So 3 to the 1/6. Your model is this. X A and B is the exact same thing as X A over B. So use this for your model. So 3 to the 1/6 is going to be 3 to the 1/6. Okay, now it's a 6th root, so if I got 6 or more, some stuff can come out. Nothing can come out. 8 to the 1/5 is going to be radical 8. 1, 5 goes there. Let's look at 4 real quick. S cubed. S cubed is going to go there. 3 is going to go, can go either here, or it can go S cubed 5 there. They're the exact same thing. But now look at this one. S cubed cubed, that's the same thing as S to the 9th. And because it's a 5th root, I can pull out 5 or more. So how many 5s are in 9? There's 1. So I can pull one of these S's out, and 4 of them stay in. And this is a good answer. So here's what I'm saying. If it is, jeez, this marker is no good. If we got the 5th root, I can rewrite it as s to the 5th times s to the 4th. Because I got a total of 9 of them in there. I can break them up, 5 here and 4 there. But this 5th root is going to cancel that 5th power. So this s is going to be on the outside, and this is still left on the inside. Okay, look at number 6. Let's do 6 and 8. 6. If you want to morph it back to a rational exponent, this is going to be 37 to the 1/3. Number 8. Alright, this is going to be, so it might be a little tricky because there's kind of 3 things in there. So maybe let's do each of them on their own. This is going to be 6 to the 1/3 times x to the 1/3 times y to the 2/3. So y has an exponent where 6 and x don't, so it's going to be a little bit different. Its fraction is going to be 2/3 instead of 1/3. Okay, let's go on. Okay, let's do, which one? Let's just hit and pick some of these. 81 to the 1/4. That's going to be 81 to the 1/4 root of 81. Okay, now the trick is always change these numbers out. 81 I'm going to change out for 9 and 9, for 3 and 3, 3 and 3. I am going to change 81 out for 3 to the 4th. Always change these numbers out for the prime factorization. Okay, now look, a 4th root of 3 to the 4th. The 4th is going to cancel 4th root, 4th power. Your answer should be 3 all by itself. 12. 4 to the -1/2. You can never have a negative exponent. You always take it to the denominator. Or if it's in the denominator, take it to the top. So 4 to the -1/2 is going to be the same thing as 1 over 4 to the 1/2. Okay, now you cannot have fractions for exponents in the bottom. But if I morph this, it's the same as 1 over the square root of 4. And square root of 4, you're in luck. This is the same thing as 2. So your answer is 1/2. So that one's not too bad. But here's what I'm talking about. Let's look at the 20. P to the -1/5 is going to be 1 over P to the 1/5. Okay, now it's illegal to have that on the bottom. So you need to be tricky with how you solve it. 1 over P to the 1/5. You need to multiply it by a clever 1. Your clever 1 is going to be P to the 4/5. Because I know when I multiply my powers, I add the exponents. So on top, 1 times P to the 4/5 is going to be P to the 4/5. But my bottom is going to be P to the 1/5 add 4/5. And that is not a fraction anymore. That's a whole number. So my top is going to be P to the 4/5. My bottom is just going to be P to the 1. And that is legal. That's totally fine. So let's look at a couple of these. Let's just do 25. 64. Bust, always swap that out for 8 and 8. Okay, I know each 8 is a 2 and a 2 and a 2. So this is the 12th root of 2 to the 6th. Okay, a 12th root can undo any powers of 12, but I only have a power of 6. So that doesn't do much. But if I morph this back, look what happens. It's going to be 2 to the 6/12, which is 2 to the 1/2, which is the square root of 2. So you can simplify these. 12, 6. Divide them, because if you look at it in a fraction, it's going to be 6/12. You simplify that to 1/2. Pretty slick. Let's look, 17, you're probably okay. 19, if you have a power to a power, you times them. So it's going to be Q to the 1/2 times 3. Make 3 a fraction, times your tops, times your bottoms. Q to the 3/2. Okay, we're almost done. Let's do some of these imaginaries. This is a multiplication. 3i times negative 2i times these two first. So that's going to be negative 6i squared. I squared is a negative 1. Negative 1 times negative 6 is positive 6. Then take that answer and times it to 5i, so you should have 30i. Number 6, if you have I to the 11th, what do you really have? If you have an imaginary times an imaginary times imaginary times, oh dear. If you do it over and over, is your answer going to be an imaginary or is it going to be real? Because you have to know this about imaginaries. I is the square root of negative 1, but I squared is a negative 1. Okay, so I to the 11th is how many squares? I know that 5 squares is 10. So I know that this right here is the exact same thing as this right here. I gotta have 11 imaginaries. Right here I got 2 of them. But if I have 5 2's, that's 10 of them. And then there's my 11th right there. So I squared, this is swapped out for a negative 1. If I have negative 1 to the 5th power, negative 1 times negative 1 times negative 1, that is a negative 1. Negative 1 multiplied by I is a negative I. So the trick is to see how many squares you have. How many squares are in 65? I squared. I know 30 squares is 60. So it's going to be 32. Because 32 squares is 64. So there's 64 I's. Here's my 65th I. Okay, 65 I's. Here we go. I squared, that's a negative 1. Now I got negative 1 32 times. And I know a negative times a negative, an even amount is going to be a positive. So this is going to be a positive I. Whereas 6 was a negative I. Okay, it's going to be the easiest. It's a plus. So I only plus my like terms. 7 plus a negative 12 is a negative 5. Negative 8i plus negative 4i is negative 12i. That's it. Just like terms. Okay, this is times. Let's look at 14. 3 times 3, that's 9. 3 times a negative 4i is negative 12i. Gee, oh dear. Not sure what I did. Okay. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. 4i times negative 4i is negative 16i squared. Combine your like terms. That's 0. 9 minus 16i squared. I squared is negative 1. A negative 16 times a negative 1 is a positive 16. 9 and a positive 16 is a 25. Easy. Okay, 15. It is illegal to have an imaginary in the bottom, just like it's illegal to have a square root in the bottom, just like it's illegal to have a fraction for an exponent. These are all illegal, illegal, illegal. So how you fix this is you times them all by a fancy 1. My 1 is just going to be I over I. Imaginary over an imaginary. So on top, times both these by I, you're going to get 8i minus 6i squared. On bottom, you're going to have 3i squared. On top, you're going to have 8i. That's a negative 1. Negative 1 times negative 6 is a positive 6. On bottom, that's a negative 1. Negative 1 times 3 is negative 3. That is my answer. Okay, number 16. If you have 2 terms here, number 15 was easy because there's only 1 term. 16, there's 2 terms. My fancy 1 is going to be tricky. It's not going to be just I, it's going to be the conjugate of this, which is going to be 4 minus 2i. 4 minus 2i on top and on bottom. So you're going to have 12i minus 6i squared on top. On bottom, you're going to have 16 minus 8i plus 8i minus 4i squared. Okay, on top, you're going to have, that's a negative 1. Negative 1 times negative 6 is positive 6 plus 12i. On the bottom, these cancel out. That's 0. I squared is negative 1 times negative 4 is a positive 4. 16 plus 4 is 20. And then 6 and 20 and 12 all are common. In the way you can divide them by 2. So that's going to be 3 plus, 3 plus 6i divided by 10. And that is it. You should feel pretty dang proud of yourselves because that is some deep stuff. And it should be comfortable. So that means you're a smart person. And that's good to be smart.